There is this problem 1551 resembling early ones, maybe I don't know, 1540. It's a very common type of problems. I know for the F Fundamentals of Engineering exam you may see something like this. Okay, so what is this about? We have a, so again, problem is 1551, and we have a barge, and there's this car, and we have this distance, it's 40 meters, and we have the mass of the car, MA, is 2,000 kilograms. We have the mass of the barge, it's 10,000 kilograms. We neglect resistance of the water, and it says somebody's driving the car. It doesn't say it was how fast, over how many seconds, a distance of 40 meters. Okay, so we have the velocity of A to the right, and we expect the barge to move to the, velocity of A to the left, we're assuming positive to be to the right, and there's the velocity of the barge. Initially they're at rest, so we say 0 plus 0, that'll be mass of the barge time initial velocity of the barge, mass of the car time initial velocity of the car relative to the ground, equals to, it will be mass of the barge times velocity of the barge, and then there is mass of the car times velocity of the car, barge relative to the ground, Okay, so what we need to find is how far the barge has traveled relative to the bottom of the lake, or fixed reference frame. All right, so what is the velocity? And by the way, we can explicit this. So again, and flip the equation, so it'll be equal 0. So I have mass of the barge times distance travel of the barge, x barge, divided by dt. And then I have negative distance traveled, so let's say x a equals, but this is distance traveled. This is distance traveled to the in relative to the barge, not relative to the ground. So we're going to see the distance traveled relative to the ground as x of barge. I put the plus here because I'm the way I'm writing it, with xb being positive to the right, the direction in which the barge is moving. Okay, so xb minus xa, this one, the 40 meters, over dt times mass of the automobile equals 0. Okay. So it being equals 0, I can just simplify and say multiply by dt. So we have mass of the barge times x of barge, which we don't know. Okay, we don't know. And then I have plus mass of automobile times distance traveled by the barge, again not known, negative mass of the automobile times XA equals 0. So from here we get XB is MA XA over will be MB plus MA. All right. And this is equal to what? With the numbers given, I have 2,000 times 40 over 10,000 plus 2,000 equals 3 zeros go away, so I have 2 times 40, that's 80 over 12, and this is 6.667 meters. Okay, so the 40 meters traveled by the car is translated into 6.67 meters. Let me call this answer of the barge. All right, so let me center it, and okay, I'm resuming recording to present you with an interesting and maybe intuitive find not discussed in the book. So I made this reference frame with the origin at the tip of the barge. Okay, and what I did, I evaluated the center of mass, assuming the center of mass of the barge is in the middle and the car is like a point. So I calculated the center of mass for the system as it was originally and for the system in the final position. So, and I used the formula for the center mass, from statics. So the bodies would be A and B. And then location of center of mass for A would be at 40 meters from the origin, and for the barge at 20 meters. And then you calculate the product MI times XI, MI times that is MA times XA, MB times XB. And applying the formula, so sum of MI XI over sum of MI, it's what I did.